So we are going to do some exercise. For example, which of the following is a tuple? So this is a tuple. This is also a tuple. But inside a tuple we have one tuple and one dictionary and one null element. Next, which of the following is a list? All of these empty list is also a list. Then writing as a list, empty list, and using the constructor operator, using the element is also a list, because at the end all of this will be inside the list. So this is a list. This is also a list. This is also a list because we can add the tuple inside a empty list using the constructor operator. There is a list where it includes two tuple. So here it is also a list. Inside a list we are trying to include two lists. So next, this constructor operator is used to add a single element to the left and front of the list. Always remember, this constructor operator will be used to add a single element. These all are single element. This is also a single element. Although it is a list, but this list is a single element. We are going to add to a list, but front of the list. The plus plus operator is used to concatenate two lists. Remember that. And which of the following this will be evaluates to 2718 inside the list. So this is evaluates to be true, and this will, because after adding with the constructor operator, 2 will be going inside the head. Next, this is also correct because we are appending two lists. Next, this is not correct because 2 is not a list. So the next thing, next set of question are follows. The value of tail 2, 1, 8 will be 718, and value of head tail 2 we will first apply tail of 2, 7, 1, 8, and that will be 718, and head of that will be 7. And value of tail we will apply first tails, it will be 7, 1, 8, then apply again the tail, and it will be 1, 8. And the value of the first will be 2, 7, in the first dictionary. Value of the third will be 618, and value of the take 2. So at most 2, but we have at most 2, so we have 6 and 1, so we add 6, 1. And value of the take 2, 6. We can take at most 2, but we only have one element, so but at most, so we can take 6. And value of the take 2 of empty list will be just an empty list. So the left appointing arrow is assignment operator. It's not on comparison operator. Now the equal operator is for testing if two values are equal, or test if the value represented by two expressions are equal. Next thing, let's say we are assigning a as 1 to a variable t. So np, and this is a wildcard. We are assigning t to np and then wildcard. So we are constructing a tuple a as 1 and assign it to variable t. This is correct. And we are breaks down a tuple into components and assign it to variable n and p. This is also correct. And n is assigned to variable a, p is assigned to variable s. This is what happening here. Next, we are going to analyze second code, where we are assigning variable, we are assigning tuple a and s to a variable node pair, and we are checking if a as this tuple is equal to node pair, then we are going to return 1, else we are going to return 2. Now the answer will, we are constructing a pair a as tuple and then assign it to a variable node pair. This is correct. And we are constructing a pair a as and compares it to content of node pair. This is also correct because we are this pair will be this node pair, content of this node pair will be assigned to variable, assign it to the pair as. So it will definitely return 1 because this is equal. Next, the last code is the, let's say we are assigning a as one tuple to a variable list, and what we are also doing is we are adding to two tuple a as 1 and as null 0 using constructor operator to a list. Now if a wildcard 0 is equal to head of the list, head means the first element of the list, which is actually equal uh, a as 0, so no, which will not be equal because a wildcard it is 0, it should be 1, then return 1, so it will not return 1. Else if wildcard a wildcard as 1 equal to head of the list, then return 2, so this is correct. So here it will return 2, and it construct a list of tuple and assign to variable named list. Yes, this is a list of tuple and we are assigning to variable of list, and we are comparing tuple containing the wildcard to head of the list. So now we are going to discuss one problem where uh, there is a water jug of uh, the capacity of water jug is 8 liter, 5 liter and 3 liter. So let me draw. Let's say there are 3 water jug for 8 liter, then another is 5 liter, another is 3 liter. So now a total number of water remain constant, which will be total number will be uh, 8 plus 5 plus 3, that will be constant, that should be 15 liter. However, while two types of transfer can be performed, two transfer moves can be performed. We can pick up a jug X and empty it into jug Y. Then we have E X E Y. E means empty. We are taking water from X and emptying into Y. So the after this operation, water in the X will be empty. Another thing, we can take X and we can fill it up to top up the jug Y. So it will be called as XFY. Now what it will do is it will fill up the Y. It will not make sure if X is emptied or not. In some cases, emptying jug X into Y may also fill up the jug Y. And filling up jug Y from jug X may also empty out jug X. So then both XEY and XFY are valid, right? And produce the same outcome. In such cases, we will ignore fill up this process and we will just use this well emptying it, because in some cases the emptying a jug is also fill up the jug. So in that case, we will call this just we are emptying the jug. Now consider this, and which contains 3 jug ABC of the capacity 12 liter, 8 liter and 5 liter. Now we are taking 12 liter, 8 liter and 5 liter. The state will be presented as a tuple, right? And this will denote the amount of water in jug A, B and C, and total will be 12 in all states. Now all states reachable from 12:00 in 0. One or more moves are shown in this figure. Now this thick line, it denotes two-way move, reversible move, and thin directed jog denotes the irreversible move. The question is this state valid or not? Now this is invalid state. Why? Well, because if you add this, it have 13, it will 5 plus 3 plus 5, it will be 13 liter, but with our only capacity is 12. We can maximum have 12 liter. We have jug of 12 liter, 8 liter and 5 liter, but our capacity is only 12 liter. So this capacity is shown that in one A is, jug number A is 5 liter, jug number 2 is 3 liter, jug number C is 5 liter is impossible. Second is the state 435 denotes what? This denotes the amount of water in the jug ABC respectively. It's not the capacity the capacity of the jug is 12, 8 and 5 liter. Next is from 435, which move will take us to 480. Now this is C and emptying it to B. Why? Because here you can say here you can see there are 5 liter, and we already know this in C jug the capacity is 5 liter. Capacity of B jug is 8 liter, capacity of A jug is 12 liter. Now if we are going to empty it jug C, which have 5 liter, and we're going to empty it into B, then it will become 8 liter. So 480 will be the option. But if we do C emptying, fill it in B, then the jug B already has 3 liter, and emptying it into or filling it into become 480. That is true. However, we already make sure that in the case when jug fill up is also equivalent to emptying, we are going to take it as an emptying the jug, not fill up the jug. Now next question. From 435 this state, the move AEB, A emptying into B will take us to 075. Correct. Why? Because in jug A there is 4 liter. Now if we are going to empty it into jug B, then jug B will have 075, not 705 or 930. Now from 435, the move C emptying into A will take us to state X. The move that will take us from X back to 435 is called reverse move. That is correct. The reverse move will be what? Well, you can say from 435, if we do C emptying into A, then the resultant state of the space will be 930. Then from X, that move will take us from the move that will take us X back to 435 is called reverse move. The reverse move will be A fill into C. Why? Because in A there is 9 liter. So we need to go to the same state where we are already was before doing the C emptying into A process. What it will be? It will be A fill into C. Why? We already know after doing C emptying into A, the state become 930. And now if we fill into C, because C, the capacity of C jug is only 5 liter. So if we are going to empty it into C from A, then it will again become 435. But we just need to fill this. A emptying into C is not possible because A already has 9 liter and the capacity of jug is only 5 liter. B emptying into A will not do the same, because if we emptying the B into A, then the state will not become 435. The state of B will become 0. That is not what we wanted. We wanted 435 again. Next, which of these following move sequence will take us from 705 to 480? So if we do C emptying into A and then A emptying in A filling into B, that will lead to 480. How? If we take the C, then we are going to empty into A, so it becomes 1200. Then we are going to A fill into B, then B already the capacity of B is only 8. We already saw that capacity of B is 8 liter. So if we do that, B become 8 and the capacity of the water present in the A will be 4, and then C will be 0. Likewise, you can check for yourself all of this move, if we do this A emptying into B, then C fill into B, then C emptying into A, after all these three steps consecutively, you will get 480 from 705 step. And likewise, C option is also correct. Now, next question is from 705. The move sequence A emptying into B and then C emptying into A, then B fill into C will take us to where? Well, if you do A emptying into B, then it will become 075. Then C emptying into A, and then it will become 570. Then B fill into C, 570 to from 570 to, let me write it down, from 570. If we do B fill into C, then it will become 525, which is our answer. Next, from 705, the moveGen function will return what? So from 705, moveGen function can be 075, correct? It can emptying A into or fill into, it cannot fill because it's only have the 7 liter, and in B the capacity of B jug is 8 liter. So if we emptying A into B, then it will become 075. Then if we emptying C into B, then it will become 750. And if we emptying or filling C into A, in that case it will be emptying into A from C, it will become 1200. In the B case, this is not possible. So what is the minimum number of moves required to go from 705 to 525? Well, you can check it for yourself. It's just needed 3 steps to go from 705 state to 525. What is the minimum number of moves required to go from 525 to 705? Minimum is 1. You just emptying B into A, this will become 705. Now, starting from 1200 using one or more move, is it possible to measure the integral volume 1, 2, 3 up to 11 liter? Yes, that is correct. You can check it for yourself. And in the given state space, each move has reverse move. No, it's you can see in a diagram, it's only 1, 2, this and the and this, all of this dark color, dark black color line will represent the reverse move, but the unidirectional line will represent the irreversible move. So there are a lot of irreversible move too. It's no, in a given state space, from each state we can reach every other state. Yes, that is correct. And in the given state space, for each state, moveGen will return exactly 4 neighbor. This is also correct. For each state, moveGen function will return exactly 4 neighbor. This is actually not correct. It cannot generate the 4 neighbor. Rabbit puzzle. Here you can see 4 rabbits are there. Now a rabbit can only jump forward. It can jump to an adjacent empty slot or jump over one rabbit and land in an empty spot. No other long jumps are allowed. Now determine whether a rabbit can cross the world. Model this problem as a state space search problem. Construct the state space manually. Such as the characteristics. Now here this rabbit and this rabbit can only jump to the right side, and this rabbit, these both rabbit which are in the left facing, sitting in the left facing the left side, can only jump in the left side, and these 2 rabbits which are facing the right can jump only in the right side. Now a state space state can be represented by 5 characteristics. For example, right, right, uh, and there is a dash. That means there is nothing in there. And left, left. Describe the start state. Where R is a rabbit that wants to go to right, and L is a rabbit wants to go to left. And dash marks the empty spots or slots. Now, possible moves from start states are 2R3. 2R3 means the second rabbit or the second position rabbit can go to third position. Then it will become R dash RLL. Or the first rabbit can go to third position. Remember, the rabbit can jump. Uh, rabbit can jump over one rabbit, but not more than one. So the position will become dash RRLL. Then fourth number rabbit can jump to L3. So 4L3 and then it become RRL dash L. And then fifth number rabbit can jump to the third position, then become RRLL dash. So observe that for a given state that the two position in from rabbit 2 is always the same. So therefore without loss of information we can represent as a move as from rabbit where 2 is implicit. It can be read from the input step. Now manually construct all the states from RR dash LL. Now you can see given the state LRL dash LR, the valid moves will be what? Valid moves will be 2R. Why? The second rabbit can move to the right. This is possible. The first rabbit uh, uh, it can go to right, and the let me see. It's a 2R and it will be 4L. Why? Because the given state the valid moves will be 2R, because second rabbit can go to uh, the second rabbit can go to third position, and 4L the left side rabbit which are in the fourth position can go to the third position. These are valid. 1L is not valid because length L side rabbit can only go to the left side. As we already can see, there is no empty slots or anything to go from first position to the left of the first position. So this is not a valid move. Next, the second is given the state RLL dash R, valid moves will be what? So valid moves is 0. Why? Because this R rabbit cannot go to the dash position because it cannot jump over 2 rabbit. The next thing is this LL rabbit cannot go to this position because LL rabbit only go to left side. Next, from RRLL dash LL, the minimum number of moves needed to reach LLRR is just 8. You can check it out. If you do the calculation, it will just become clear. Now from RRLL, number of paths to LLRR is 2. Why? Because there are 2 paths where from RRLL we can go to LLRR, and in one step we can have the in one path we can have 8 steps. In another we might have different number of steps. Next, in given graph, how many dead end exist? So we can check it out, and if dead end is just a state that does not transition into another state. We can here we have already got one dead end. If you can see here, this is a dead end state. So from this we cannot go to another state because there is no valid move from here. This is a dead end. So like this, in that graph there will be 5 dead end. Now in graph, number of unique state will be 23. And in the graph, each move has a reverse move. That is also false. We can see in the graph that there is no reverse move for some of the position or some of the state. So for example, this move RLL dash R, this position does not have a reverse move because there is no valid move we can do. This is a dead end. Now in the graph, there is a move which has reverse move, false. Now in the graph, from each state, is it possible to reach every other state? This is also false. We can say, you can see in this graph, for every state we are going from here. We can see here from RR dash LL. If we go to R dash RLL, we cannot go back to RR dash LL. So there is no reverse move. There will not be reverse move for any position. If you even try, because R cannot go to the left, right? R cannot go to the left because R only allowed position is R has to go to the right position. So there is no reverse move for any state. So now we are going to discuss about the state space and movegen function. So here we have a movegen function and a set of state space graphs are given below. Now we need to see what will be the state space graph for this movegen function. And if you can see that for S, the open node will be A and B. So graph 1 resemble with this condition. Then from A, the next one will be which has with A. Then the open node for A is CDS. You can see C, then D, then S. Then we can go to B. Then the open node for B will be DGS. So B will D and G and S. Then we will search next open node C. So it will be ABGS. So for C it should be A, B, Z, S. Then we will go to search for D. D open node is A and B. Then we will lastly search for G. A, B, C, D. For G it is A, B, C, and D. Now here we can see this is unidirectional graph, unidirectional line. This is bidirectional line. Where there is no arrow, it is bidirectional. If there is one arrow, it is unidirectional. So graph 1 and graph 3 will resemble this. For S, it can go to A and B. Then for A, it can go to CDS, C, D, and S. Then for B, it will go to DGS. For B, it will go to D, Z, and S. Then for C, it will go to A, B, G, S. For C, it will go to A, B, Z, and S, like that. Next is we have given a state space graph, and we need to find out which movegen function will satisfy this. So movegen tool satisfy this. Why? For S, it will go to A, B. For S, it will go to A and B. This bidirectional line. Then for A, the next will be A. For A, it will go to CDS. It will go to C, D, and S. Then for B, it will go to DGS. For B, it will go to D, Z, and S. Then for C, it should go to ABGS, because here you can see A, B, Z, and S. And for D, it goes to A and B. For D, it goes to A and B. So likewise, the movegen function tool satisfy this, and movegen function 4 will satisfy this. You can check it out for yourself. You can check this for yourself. Now, which statement will be true? A movegen function will describe exactly one state space. So this movegen function will satisfy only this state space. But for a given state space, there can be two movegen function. So next we will see the problem for So here we can notice this that let the open node be PQRSTUVW. Then what of this will be true? Now, if we consider the BF as breadth first search, it will pick node P and then apply the goal test function to P. And if we pick DFS, it will also pick node P and then apply goal test function to P. This is wrong. BFS will not pick W. The BFS will always pick the first one, and DFS will also will not pick W. And then next question is, let's open be NAFLT. Then DFS picks up node N from open and call goal test N, which returns false. Then what? Then algorithm DFS will call moveGen of N. The next step will be algorithm will call moveGen and N, and then after that it will go to the open list. It will go to open list. If it is false, then the algorithm will call the moveGen N. If there is open NAFLT, if DFS picks up node N and open calls goal test and returns is false, then it will also called moveGen of N. Now let open be NAFLT and DFS has called moveGen N, and the list of new node to be added to open is MBH. After that open will be MBH will be added to where in this new open list. So if it is DFS, updated open list will become in front. So this is like this is not a queue. BFS is like a queue. BFS, the last one will first one will be first out. So it is first in first out. But in DFS it is last in first out. So MBS was comes here in last. Last means a new node, but it will be the one which go into the first position. It will be first out. But for BFS, if the open list NAFLT and a new nodes to be open, new nodes to be added is MBH, then updated open will be in the last MBH, in the last of the open list, because BFS follows last first in first out. So the first one which was already there, NAFLT will be at the beginning, but the MBH will become at last. So next, we have given a state space. This is the set of possible states. Each state can be seen as a node in an implicit graph. Now, a neighborhood function we will call moveGen function takes node as input and returns the neighbor of n that can be reached in one move. So n can move to A or D or E or B or C. So this is nearest neighbor of n. So this will be called as a when moveGen function of n will call, then this in the open list of n will be this node A, C, B, E and D will be present. Now the neighbors of node n are A, B, C, D, E, and the names of node arbitrarily decided, and moveGen function returns list of neighbor in order in which it returns the neighbor depends on the implementation. Because in case of BFS it will follow first in first out, and in case of DFS it will follow last in first out. Above figure says that list might be CBEDA, yeah, correct, and but it also could be ABCDE. So let's see a simple state space. This following graph has 24 nodes. A, K, F, these all are called nodes, and edges are all bidirectional because there is no arrow in here, which means the algorithm can move in either direction. Edges depict moveGen function. Now, we do not know the order in which moveGen function generates neighbors. The search algorithm does not maintain closed list and adds all neighbors to open. So which of the following are possibly valid order in which depth first search visit the next 5 nodes starting from J? Let's see. If it is depth first search, then it will follow last in first out. The last one will be the first to um, in the first to get in the open list. Now from starting from J, J is here. So for J it has K, L, so it has K, then K, I, N. But then it will go to K. But and what are the neighbors of K? Well, K have neighbors L, P, O, J, E, F. So L, P, O, J, E, F will be comes in the begin in the list open list of J. So it will become JK because for J J the neighbors were K, I, N, but for then we will call K, then after K it will be L, and then what is the name, then L, P, O, J, E, F, but we choose L, then L will comes in first, so we need to choose L. So if we choose L, the neighbors of L is only K, then K will be present. Then again from K the Movegen function will say that you have neighbors, here are the neighbors of K which are L, P, O, J, E, F, then it will go to L again, and this will continue. So this is the option. Now what might be other option? So if it can go to N, like we can select J, the neighbors of J is N, I, K, then it will go to N. Then if it goes to N, okay, let me see. So if it is goes to N, then the neighbors of N is again J. Then again J will pick up N, I, K. Then N will becomes first. Then it will go to N. Then J, N only have the neighbor J. It will go on like J N, J N, J N. Then the last one is if it keep J K, J K I N. The neighbors of J are K, I, and N. Then it will go to K. Then for K, it have neighbors P, O, J, E, F. Then it will go to P. But we already know the neighbors of P are present. So P as neighbor Q, Q, W, K. But it is DFS. So this neighbor Q, W, K will becomes beginning in the open list. Then it will become it will go to search for Q. Q has neighbor R, then it will go to R, then R has neighbor Q, so it will go to Q again. So it will become JK PQ RQ. Next, which of these following is possible? Following are possible failure order in which breadth first search visit the next 5 node. So for breadth first search, I can show you. For breadth first search for J can have the neighbors K, N, and I. But we will go to then the next thing we will go to K. But we already know this will be the open list of J, and we will go to K. So K has a list which is K has a list which is L, P, O, J, E, F. Now for that, the open list of J is just K, N, I. But we already know the K has E, F, L, P, O, J. But this will come at last because it is DFS. So K is gone, first J is gone, J is gone, then next K is gone, J is gone, K is gone, then next we will search for N. N has only value, so for K, when it is searched, it will become like L, F, E, J, then O, then P. But we will search for N, so N have neighbor J, so it will come to last, J. Then it will go to search for I also have J. So the first 5 will be like this: J, K, N, I, E, F. That will be the first 5 node. So if you do this, bed first search will give a result like this, because it will bed first search will always add the new nodes at the last. Which of these possible for failure with depth first search visit the next starting from K? You can check this. Likewise, this is similar to starting from J. Then next is this search algorithm does maintain a closed list and does not add neighbors already visited to open. Then what will happen? Then if we use the depth first search visiting from J, it will produce JKLOST. Why? Let's see. So for J, it has KIN. So then we'll go to K. K have neighbors LPOJEF. So it will become JK L P O J E F I N, because it is depth first search. And J will not be present because we are maintaining a closed list. So J will not be present. J is already seen. J is already seen. J will also here will not be present. Next, what are the next node will be for L. So L has only K, but K is already seen, so K will not be present. So it will become from L, it will go LPOEFIN, but it have a value which is O. So it can go to O. So if it is go to O, and it become LO, then we will take P, then E, F, I, N. Then we will go L have O do not have L is already seen. O do not have O have neighbors. So it will go to S and T. So O will go to S. S will come in the beginning because this is depth first search, DFS. So S T P E F I N. Then it will be like this: JK. Then it was LOST. So answer will be JKLOST. Likewise, for BFS, it will be different. For Bedford search, JK, it will become JKNIOP. Why? Because you can clearly see here how BFS will work. J have neighbors like this. Now we already seen J, so J will be cancelled. Next K. K have neighbors O, P, L, F, E. J is here, but we did not need to write J because closed list is present. And in the closed list, J is already there because we already seen J. Now, from K we'll go to N, and for N it has already J, but J is already seen. Then we will go to I, but I have only neighbor J, so J is already seen, so this become N, then next become I, and then we will go to O, and O have neighbor which is S and T, but S and T will be at the last. O, P, L, F, E, S and T. We only need 5 nodes. So JKNIO, and it will go to P. The next node is P. So P. So what we get? JKNIOP. This is the answer. J, uh, JKNIOP. Likewise, if we choose JIN, then it will become KLP. If you can choose JIK, it will become NEP. The next, state space with cycle. The following graphs has the same 24 nodes and contain additional edges that produce cycle. For example, EFKE. You can see here EFKE. This is a cycle. This means that there may be more than one path between two nodes. For example, JF, JKLZ, so from JKLZ or JKFZ, and many more paths exist between J and Z. We can go from J, E, F, Z, likewise. So we do not know the order in which moves generate neighbors. The search algorithm does not maintain closed list on neighbors open. Which of the following are possible order? Depth first search for the next 5 nodes. If it's starting from G, then it will become GLQ, PKL. Why? You can see from here. So starting from G, it will go. It is depth first search. So it has neighbor. L, F, H, M. It will go to L. L has neighbor Q, K, F. Then, so here I'm going to show by writing. So Z has neighbor, Z has neighbor L, F, H, M. L, F, H, M. I'm going to go to L. So big L has neighbor Q, K, F, Z. Now, but it is DFS, so it will become it will comes in the beginning. So L will have Q, Q, K, Q, K, F, Z, F, H, M. The next ZLQ, all of this done. Then what to be done? What is the F? It did not need to write F here because F is already present. So next we need to write for Q. So for Q we have P, L, R, W. For Q we have P, P, K, L, W. And after that all of this will come. Q is already there, so we need to write Q. This will come here. Then we will go to P because Q is already done. We'll go to P, and P have neighbors, which is P have neighbors K, Q, W, O. K, Q, W, O. Oh, W is already present, we did not need to write. Then it will go to, after P, it will go to K. And for K, it has neighbor L, F, E, J, O, P. So L, F, E, like this. So what we get? G, L, Q, P, K, L. This is our answer. So from here, a search tree, not the state space. This is a search tree. Now at the point where goal test returns true, the start node is S and goal node is Z. This is our goal node. We need to go from S to goal node. Study the search tree and answer this question. Now DFS has just finished inspecting H, node H. Now list the contents of open. So what could be in the open list? The open list contain pairs and ignore the parent list, only the nodes which occur in the open list. So since it is DFS, so S can go to A and B, then it can go, then it will go to A. A has nodes C, D, S. Then because it is DFS, then C has node HI, then it will go to H. So H will contain node D, then B and I. So it will become IDB. Okay, let me show you by writing this. So as starting from S, the start node will search and it will get A and B as open node. S, A and B. And it will go to search for A and it will see that it has only C and D. So it will become S, A, C, D and B. We will go to last, although it was at the beginning because it is DFS. Then it will search for A. It will search for A. It got C and D, and it will search for C. So S, A, C, H, I, D and B. Now it will search for H, so it becomes S, A, C, H, and on the open list it have only I, D, B. So this is our answer. Next question is DFS just finished inspecting S. Now this is the content of closed. Was the closed list? Well, closed list where we have already seen H and A, then C and H. So we'll write from the last one. So HCAS. We saw first H, then C, then before that A, then before that S. But if it is DFS, now if it is DFS, it will start inspecting as H, list of all other inspectors over, enter the nodes in the order they were inspected. What is the inspection order for DFS? I can show you here. For DFS, it will become first. It will search for DFS. It will become S. So S, then open list will be A and B. S is seen. S already seen. Then it will search for 8 C and D. Then the open list will be C and D. Then it will search for B. No, yeah, it will search for B. So B has the neighbors E and F. Then it will search for C. Then C will have H and I. Then it will search for D. D will have Z and K. And it will go to E. E have uh, E have the LM, so it will become E F H I J K L M. Then it will go to F. It will have Z and N. So F H I J K L M Z N. Then it will go to H. H have node. In the list of open, it will become I J K L M Z N. So for DFS, this for DFS, it is for DFS inspecting the DFS just finished inspecting H. Content of open is IDB. For DFS in the closed list will be like this, and for BFS it will IJKLMGN, you can see that. And for BFS in the closed list we'll have HFEDCBAS. Now we are going to learn about search tree and simple search. Well, simple for DFS. For BFS, we have already for. Let me show you about what is DFI. What is DFI? This is for DFS, BFS, and DFID. We have already seen DFS and BFS. Let me show you DFID. Let me show if it is present. This is for BFS and DFS simple search, and this is for simple search in DFS and BFS. This is for BFS case 1, BFS case 2, BFS case 3, and this is for DFIDN, DFIDN. This is for DFIDC. This is for DFS, BFS only.